All right, you guys are still on proportional sides and similar triangles. This is slide number 12. All right, so I'm going to come down here and click on my GeoGebra. All right, so we got a different figure here. Looks like a triangle. I'm not sure what this D is hanging out here for. I guess we'll find out. Okay. Measure the lengths of AD and DB. All right, so we got to find the measure of AD and DB. All right, so AD was 1.875. Can't make that easy, can they? All right, and DB, 3.125. Can't make that one easy either. All right, now what's the ratio? Okay, ratio means to divide them. So I'm going to take 1.875 divide by 3.125. See what my answer is. 0.875 divided by 3.125. Looks like I get a ratio of 0.6. 0.6. All right, well, that's what they asked me to do. Yep, that's it. Okay, hit submit. Okay, got it. Boom. All right, question 2. Measure the length of AC. All right, so come back up here, distance or length, A to C. I got a 13. All right, use coordinate algebra to locate point E on AC such that the ratio of AE to EC is equal to the ratio of AD to DB. Show how you derived your answer. Let X and AC minus X represent the two line segments that make up AC. Okay, I think I understand what they're saying. All right, so we said AC was 13, wasn't it? Yeah, AC is 13. Okay. All right, so what they're saying is that AC is going to be our X. All right, that means that EC is going to be our 13 minus X. Whoop, minus X. All right, so yeah, represent AC. Okay, 13 minus X. Okay, so now we got the same proportion. All right, so proportional, okay, it's going to be kind of hard to write. Let me do my equation editor. I need a box over a box for a fraction. So X will be on top, and the 13 minus X will be on the bottom. All right, there's my ratio. Now that's going to equal 0.6 because that's the same ratio I found up in question number 1. Okay, so it looks like I gotta solve an equation here. Well, if 0.6 over 1 was a proportion, I would cross multiply. So I think that's what I'm going to have to do. I'm going to have to do the opposite of dividing by 13 minus x, and that's to multiply by 13 minus x. All right, so that's going to be x equals 0.6 times 13 minus x. All right, so I'm just doing the opposite of dividing by 13 minus x. It will cross off on the left side and then multiply over here, which means I've got to do the distributive property. All right, so 0.6 times 13. I have no idea what that is. 0.6 times 13. All right, 7.8. So 7.8 minus 0.6x, because 0.6 times x is 0.6x. Okay, let's see. Now I got to get my x's on the same side. So I'm going to add 0.6 to the other side. So x plus 0.6x equals 7.8 because it goes away on this side. So I'm going to combine my like terms. Well, 1 plus 0.6 is 1.6x equals 7.8. All right, let me move this down so I can see what I'm doing here. The opposite of multiplying by 1.6 is to divide by 1.6 on the other side. So 7.8 divided by 1.6. Let's do that. 7.8 divided by 1.6. I got 4.875. 4.875. Okay. All right, so that's going to be from A to C, because that's what X was. A to C was X up here, so A to C is 4.875. Okay, that means E to C is 13 minus that. So now I've got to say, okay, well, 13 minus 4.875. All right, well, let's find out what that number is. 13 minus 4.875. They don't make this easy, do they? All right, I got 8.125. 8.125. All right, so I've got the length of AC, and now I've got the length of EC. Okay, so let's see. Where was A? A is 1, 1. A is at 1, 1. So I got to go over from that. I got to go from that 4.875, don't I? I do. I got to go over. Okay. I got it. A is 1, 1. All right. So if I say that 1 plus 4.875, then I get the coordinate 5.875, 1. So there's my E, right? Locate E, yeah. So that's my E. Hot darn. Man, they don't make that easy. So my E is going to be basically at 5.875. So my E is going to be right about there. Now, do I have to draw it? Show that you derived your answer. Let X, okay, so use a coordinate algebra to locate point E. All right, so I need an E at 5.8751. Now, the easiest way to do that is to use my input. So come down here, open a parenthesis, put in 5.875, comma 1, close my parenthesis. Now, when I hit enter, that dot that I'm seeing right here is going to have an E on it. Aha! There you go. Same ratio. My gosh, they don't make that easy. I definitely don't like the way they had us do this, but okay. They're the same ratio. They're the same 0.6 ratio. Woo, that's a tough one. Huh, look at that. Did it exactly right. I love it. 8.125, same thing I got. And they got 5.875 and the one, same thing I got. Right on. Well, that made me think, y'all. That one made me think. I don't like that. All right, place point E that you found in question 2. Okay, I've already done that. Okay, remember, there's E right there. Draw a line passing through D and E. And measure and record the slopes. Okay, so I need to draw a line passing through DE. Okay, well, my line is up here. And I need to draw a line through DE, so I'm going to click on D, then E. So there's my line. It looks like it might be parallel to BC. Might be. That would be the same slope for that to happen. So I guess that's why we're finding the slope of DE and BC. So slope of DE and the slope of BC. All right, we're going to do DE first. So slope is under that angle icon. The distance is all the same, so slope. So I'm going to click on this segment, and I got negative 0.4. Come down here and click on BC, and oh, yep, they are parallel. Look, they are the same slope, negative 0.4. So negative 0.4, negative 0.4. And I bet you the next question is going to ask me what that means, that they are parallel to each other, you guys. Parallel lines have the same slope. So based on the slopes, what can you say about the relationship? What did I tell you? Can I call it or what? The lines are parallel. Parallel lines have the same slope. Yeah, look at that, parallel. I'm good at calling this stuff, you guys, so hit submit. All right, so that's slide 12 of 21. And I guess the takeaway from this is that the ratios to be the same. Wow. Parallel lines have the same slope. So, all right, because that's slide 12, you guys.